Welcome back to the course Basics of Mechanical Engineering 3. This is the third course in the series of the Basics of Mechanical Engineering 1, 2 and 3 that we have been bringing in front of you from the last 3 sessions. Basics of Mechanical Engineering 1 discussed about the basics, engineering mechanics, strength of materials, theory of machines, some part of machine design, that is something understandable for the first year and the second year level of the students of BTech engineering and the diploma students as well. The second part of the course series talked about very basics manufacturing. For example, we talked about casting, we talked about machining, after talking about welding and other machining or manufacturing processes as well. In this part, we talked about the thermodynamics and fluid mechanics. In all the 3 courses, we had been taking tutorial sessions to make you understand the real life problems, how do we tackle the data when it comes in the terms of manufacturing, when it comes in the terms of designing a boiler efficiency or understanding boiler efficiency or so, for example. Also, we had been going through virtual laboratory demonstrations so that we showcase you in the virtual environment while sitting at your home itself using your laptop, when the setup is available on the computer, how do you click or where do you switch on and off to have an experimental setup run to find the readings and observation and do your calculations. This is the 12th week of the third part, which is the last week of the overall 3 course series. In this, I am going to talk about something that is not directly part of manufacturing, but without that, talking about manufacturing, working in manufacturing, understanding manufacturing stays incomplete. That is engineering statistics. Whatever I have been talking about in the numericals, majorly I took averages only. I took median, maybe the middle point. Those were all part of statistics, and this you had been studying from your school times. Now, I will give you little more insights on what is the real need of statistics in engineering. Yes, I will start from the measures of central tendency, that is mean, mode, median, mid-range, etc., and give you some more information regarding these specific parameters or specific measures than you know already. Then I will also talk about the kinds of statistics, descriptive statistics, inferential statistics. There are kinds we will talk about. Then we will talk about distributions. When we talk about taking the data or collecting the data, when the data is collected, first the data is cleaned for any missing values, for any things which is little not required or which is outlier. All those things are taken away. Then we try to work upon the data to plot something to understand the behavior, like I told you to plot about the characteristics curve between the efficiency and the input pressure in the virtual laboratory demonstrations. Those also I will try to show you in the Excel sheet in this week. Then I will talk about hypothesis testing, which is inferential statistics. Whenever we design any experimental theory, when I say experimental theory, theory is based upon the experiments. Number of experiments are run. When all the time these experiments are giving exactly similar results. When I say exactly similar, I am not talking about same. Exactly similar, because there could be 0.00001% error. I am talking about 5 zeros and then 1. For example, errors are always there. It could be at 6 sigma level, 9 sigma level, or maybe 3 sigma level. What is sigma here? It is standard deviation that I will talk to you about in this week itself. Let me start with very first lecture of the week 12 that talks about basics of engineering statistics. I will just introduce what is statistics, importance of it, use of statistics in mechanical engineering, types of statistics, application areas and limitation, some terms in statistics which are regular you know already and which are something that we require more to understand the kinds of statistics. Then stages in statistical investigation, data collection and data presentation. What is statistics? Statistics is a branch of mathematics, yet a science which concerns with collecting, organizing, analyzing and interpreting numerical data. You see the steps. What is collecting, then organizing, then analyzing, then interpreting. There are anyway 5 steps. I will talk about that because it is not only interpreting, we also need to present the data. That I will talk about when I will go through the slides further. It is recognized as distinct scientific discipline due to its broad applications across numerous fields including science, economics, healthcare, social science and so. It helps make sense of complex data through quantitative models. It plays a critical role in decision making in fields like weather forecasting, stock market analysis, insurance and data science. Talk about very general data presentation, graphical presentation. I will talk about line diagram, bar graph, pie chart. Nowadays you are getting a different kind of a chart. You are getting in the stock market, they show you tree chart, they show you fan chart. Different kinds of charts are there which give you more deep information for those specifically understanding a specific kind of a chart. There are courses available. People are producing their own personal courses for which for 1 hour they will teach you what is the way you read this chart, what is the way you present your data in a specific kind of chart. Now, why is statistics important? Statistics and statistical analysis play a vital role in many fields such as business, engineering, economics, healthcare. While monitoring, observing from one's own office, it helps to gather, classify and simplify data. It provides concrete information about problems and issues. It facilitates reliable and objective decision making. It presents facts and interpretations in a precise and definite form. So, statistics is a study of data. When the domain of study is properties of data, it comes under descriptive statistics. When it is concluding the data, it comes under inferential statistics. This I will talk about. Engineering statistics combines engineering and statistics using scientific methods for analyzing data. So, we can compare, we can predict, we can formalize a specific method how to have a specific comparison between 2 kinds of the maybe any setups, mechanical setups, maybe 2 kinds of the boilers. What is the efficiency of boiler 1, efficiency of boiler 2, number of boilers to be tested, number of nozzles to be tested to be put on the boiler, to understand the quality of the nozzle to be put on the boiler. Now, all these things could be done using statistics. We need to have data for that. Engineering statistics involve data concerning manufacturing processes such as component dimensions. If I am talking about a nozzle to be fit right in a specific slot in the boiler. That nozzle has to have a tolerance equivalent to what boiler has this specific hole there or specific thread there. Now, we talked about the tolerances in the first part of the Basics of Mechanical Engineering course series. Tolerances could be clearance tolerance, or this is I am talking about a fit, it could be clearance fit, it could be interference fit, it could be transition fit. For this specific kind of fit, if suppose we have 100 nozzles, we have to select 5 out of them, we might have to test all the nozzles maybe. This is known as sensor survey. Out of all the nozzles, we will see the dimensions of the nozzle, dimension of the hole where it is to be fit. Then we will measure. Then these dimensions, component dimensions are the part of the data collection. Then comes tolerances. Interference fit is very tight fit. For example, a pen putting in a pocket, that is a very loose fit. Putting the cap of the pen on, that is a little interference fit, that is why it gives a click sound. Then transition fit is between the interference fit and the clearance fit. Type of material, that is very important as well. If you are talking about boilers, we will talk about the nozzles made out of material that could bear this high temperature of the steam. Generally, mild steel nozzles could not be used directly there. SS, copper, these kinds of nozzles would be used there. Fabrication process control. When I say fabrication process control, if we say first is the kind of fabrication process that we need to select, whether it is manufacturing through 3D printing or it is manufacturing through regular machining. Regular machining in this kind of the processes would be CNC machining, computer numerical control machining. In those, we could see whether it is a one component that it is required is manufactured in 2 parts, that is part 1 or part 2, then welded together, or single part is manufactured in just one go. Fabrication process control, that is also part of the data that is concerning manufacturing processes. Mechanical engineers use principles of calculus, statistics and other advanced subjects for analysis, design and troubleshooting in their work. Using statistical methods is essential for mechanical engineers to design, validate, hypothesize, maintain quality control and create innovative solutions. What are the types of statistics? There are multiple types of statistics. I will talk about descriptive and inferential statistics. Other than that, we have predictive statistics. What is predictive? We predict about the future, we predict about the demand, we predict about the weather. That is predictive statistics. Prescriptive statistics. After descriptive and inferential, prescriptive, prescribing something, giving a decision, giving a detailed information, or this should be the call that you should take on a specific kind of a selection of a boiler, selection of the machinery that you will work on, selection of the material that you have. That is prescription based upon the statistical background. That is prescription based upon an inference. What is it? Inference. That is inferential statistics. This we will keep talking about in this week throughout. Descriptive statistics have measures of central tendency, that is mean, mode, median, measures of variability and graphical presentation. That is, we describe the data only. We collect the data, we describe what is the data kind of. That is descriptive statistics. To talk about little detail and some examples in these, descriptive statistics, the initial phase of statistical analysis focusing on data processing tasks such as collection, organization, presentation and a raw analysis. It highlights key features of data sample without making inferences. This is very important, without making inferences, because if it is inferences to be made out of it, it is inferential statistics. And no conclusions beyond the observed data set or sample that is taken. Descriptive statistics describes the nature and characteristics of the observed data quantitatively without making conclusions or generalizations. When we say quantitatively, we are talking about using a sample. We talk about what is sampling inspection, what is census inspection. We call it inspection or survey. Sampling is when we take a small part of the overall lot. Census is when the whole part is done. We will talk about that, and why sampling is important, that part also will be covered. Some of the examples of descriptive statistics in machining. See the statement, average surface roughness of 50 turned steel samples was measured to be 2.5 micrometer Ra. That is, surface roughness is the parameter. I will call it, this is the response parameter that has been taken from specific kind of the observations. What are the number of observations? 50 turned steel samples. And what is the final average value? That is 2.5 micrometer Ra. We are just reporting it. We are just describing the data. Nothing is an inference out of it. Compressors, during last week's test, the discharge pressure of a centrifugal compressor ranged from 6 bar to 9 bar. This is a complete statement during the last week test. It tells about the time period when the test was taken. That is, we are describing the data only. The parameter here is discharge pressure of what? Which equipment? Centrifugal compressor. This range from 6 bar to 9 bar. Boilers. Efficiency of a boiler operated at IIT Kanpur's power plant last month averaged 82%. There are boilers here. Just besides IIT Kanpur, we have a small area called as Panki, where the power plants are there. The boiler efficiency of Panki that operated for IIT Kanpur monthly averaged at 82%. That is the boiler efficiency. This is a descriptive statement. In IC engines, in a performance test, the brake thermal efficiency of a 4-cylinder diesel engine was found to be 28% at full load. You see the statement, the parameter, brake thermal efficiency. When I say parameter, this is response parameter. The equipment under study. Then we talk about the value. What is the value that came out of, and what is the condition? This is environmental condition. using the word environmental here, that doesn't mean we're talking about the overall environment. We're talking about in what condition is this run. In full load, it is 28%. In half load, it could be 46% or something. In heat exchangers, the log mean temperature difference, that is LMTD, recorded across a shell and tube heat exchanger was 45 degrees during steady state operation. This is environmental condition, 45 degrees centigrade is value. Shell and tube heat exchanger is a system or equipment under study. What is being recorded or what is being studied, the parameter is LMTD. Nozzles, the velocity of steam measured at the nozzle exit during an experiment varied between 420 meters per second and 460 meters per second. This is a range. I am giving you certain terms here. For example, I am talking about response parameter, I am talking about range, I am talking about the system under study, I am talking about condition. These are statistical terms which I will talk about in the coming slides as well. Now, in descriptive statistics, there are two major measures of kind. One is central tendency, another is measure of variability. Central tendency is mean, median, mode. This means if the data is there, where is the center of the data? Mean or average is a center, median is between the counts, that is a center, mode is the maximum value, it is also a center. This is a measure of central tendency. Other than that, mid range is also a center. Then across the center we have variability, that is we talk about standard deviation or variance, minimum maximum values of variables, curtices and skewness. From the center, what is the spread? Mean could be whatever we have taken. Suppose mean was 2.5 micrometers of the roughness value, 2.5 micrometer roughness. The standard deviation could be this large spread or it could be very small spread. That means it could be varying from 2 micrometer to 3 micrometer, average is 2.5 micrometers. It could be varying from 0.5 micrometers to 4.5 micrometers, but the average is 2.5 micrometers. So, what is the spread? This is variance or standard deviation, that is how it is varying. Minimum value and maximum value, that is also a range. Maximum value minus minimum value is range. 4.5 micrometers minus 0.5 micrometers is 4, that is range, a bigger range. Then 3 micrometers minus 2 micrometers, that is 1 micrometer, that is a smaller range. So, this is measure of variability. This also we will talk about in detail. Then comes the other type, that is inferential statistics. It involves making generalizations and drawing conclusions or inferences about specific characteristics of a population based on information obtained from samples. It includes methods like hypothesis testing, confidence intervals, regression analysis, analysis of variance, chi-square tests, etc. I will cover some of these methods here in this week. These techniques allow researchers to analyze a sample's data and make predictions, generalizations or conclusions about a larger population. Let us see the examples in the same fields that I talked about: machining, compressors, boilers, IC engines, etc. In machining, an inferential statement you see, based upon toolware data from 30 cutting tests, it is estimated that average tool life in turning AISI 1040 steel is 45 minutes under the same cutting conditions. This is an inferential statement. In compressors, for experiments on 5 test units, it is predicted that average isentropic efficiency of this type of compressor will be around 78% for all manufacturing units. Let us see this statement. It talks about something taken from a small number, 5 test units only, and then they say for all manufacturing units. That is, a small number is tested, only 5 units are tested, and we say throughout the manufacturing unit this is replicable. This is known as replicability. It is known as interchangeability of the results as well. Interchangeability, replicability, these are terms. When a small sample gives a similar kind of the results for a specific confidence, we call it confidence intervals, that we will talk about. They say 78% for all manufacturing units. This is the isentropic efficiency that would be there. So, this is known as sampling, that also we will talk. Boilers using heat loss from 10 trial runs, it is forecast that the boiler efficiency will drop by 5% after 1 year of continuous operation. IC engines. From a set of endurance tests, it is inferred that diesel engines using biodiesel blends can reduce carbon monoxide emissions by about 20% compared to conventional diesel across similar models. They say biodiesel blends will reduce carbon dioxide emissions. Heat exchangers. Analyzing test results from 3 prototypes, it is estimated that new design of compact heat exchanger will achieve 15% higher effectiveness in industrial use. This is an inference, it's a kind of a deterministic statement. Nozzles from CFD simulations, that is computational fluid dynamics simulations, validated by experiments, it is predicted that the supersonic nozzle design will deliver an exit velocity of around 1200 meters per second when scaled up to full size. So, these are inferential statements. These have a lot of data, I would say analysis or analytics as well behind them. Hypothesis testing had been conducted, the regression analysis might have been taken, the analysis of variance might have been taken. So, based upon certain test, like I talked about one of the tests in the previous slides, chi-square test or maybe t-test, these all inferences have come. Now, let me have a quick glance over the overall differences between descriptive and inferential statistics. Descriptive statistics where gives information about raw data which describes the data in some manner. Inferential statistics makes inference about the population using data drawn from the population. Descriptive statistics helps in organizing, analyzing and to present the data in a meaningful manner. On the other hand, inferential statistics helps us to compare the data and make hypotheses and prediction based upon the data. Descriptive statistics used to describe a situation only. However, inferential statistics helps us to explain the chance of occurrence of an event. Descriptive statistics explain already known data limited to a sample or a population having small size. However, the attempt of the inferential statistics is to reach the conclusion about the population. The descriptive statistics work can be achieved with the help of charts, graphs and tables only made to describe what kind of data it is. In inferential statistics, probability is always used. Certain applications of engineering statistics. In engineering, it helps in enhancing product designs, testing product performance, determining reliability and maintainability and developing safer flight control systems for airports, etc. and for planning of the technology. In business, estimating the volume of retail sales, designing efficient inventory management systems, producing auditing and accounting procedures, improving industrial working conditions and assessing the market potential for new products. In quality control, the techniques of statistics are developed for evaluating the quality through proper sampling, in-process control, consumer surveys and experimental design in product development. Recognizing its significance, many large organizations have established their own SQC department, Statistical Quality Control Department, what we call as quality department. And there are big organizations such as BSI, such as TUV, which helps us in developing our own QMS, quality management systems, which we generally know from the term as ISO systems. For example, IIT Kanpur has MedTech facility that is ISO 13485 certified. So, whatever is being done in this facility, the material could be tracked, the people who are working on that could be tracked, the processes, how those going, that could be tracked, prototype developing is happening in this facility. So, here quality management system is taken from BSI, it is British standards, who develop these standards for medical devices, and statistical quality control, statistical data analysis, statistical data presentation is used to maintain the quality within a specific limit, that is quality conformance is being assured there. In economics, key indicators such as trade volume, labor force size, living standards are measured. This field also involves analyzing consumer behavior, computing national income accounts and formulating economic laws, with regression analysis being extensively used. Health and medicine, Statistics play a crucial role in developing and testing new drugs, enhancing medical care, diagnosing and treating diseases, with inferential statistics being particularly significant. In biology, statistics helps to explore species interactions with their environment, create theoretical models of the nervous system, and study genetic evolution. In psychology, statistics are used to measure learning ability, intelligence and personality traits, as well as to develop psychological scales and understand abnormal behavior. With so much of the use of statistics, there is always a limitation or demerits associated with it. What are the limitations of statistics? Statistics focuses and provides results based on data that can be measured and quantified rather than individual cases. If data is not a right fit to the present scenario or the current scenario, whatever statistical results are there based upon the data, that is the past data, would not fit right to the current scenario. It does not address qualitative aspects, that is, it concentrates solely on numerical data, though there are qualitative aspects that could be also quantified or statistics could be used in them. For example, yes or no. If multiple times you do yes and no, you purchase something on Amazon, you purchase a nozzle for your maybe laser cutting. For the specific nozzle, you will have a rating. Rating is suppose 4.2. From there, where this 4.2 number has come. When they say 4.2 rating is there from the 5,000 users. Different users are given different rating. That is a qualitative rating. Qualitative data. They out of the 5 they have given their whatever star 2, 3, 4, 5, 5, 5, 4, 2, 3. These are all averaged and average is 4.2. This is how the qualitative data, they have given only quality. Out of the 5 stars, this is the star I give. Then converting it to quantitative is 4.2 is a quantity, now a number that has come. So that is one, but most of the quantitative part does not allow the qualitative aspects of the problem to be addressed. Statistical results cannot become universal truth, hence can be misused. There could be cheating through scales using statistics. Now, once we have known the limitations of statistics, let me now talk about some of the terms which I use in statistics. I have been using certain terms here. I have been talking about the population, talking about sample, I am talking about the qualitative, quantitative data. What are these terms? And I will keep using these terms throughout this week. What are these terms? Let me talk about. Population. This is a large group of data or large number of measurements that is known as population. A population can be finite or infinite. For example, number of students in a class, number of engines produced in an industry over a span of time. These are finite population. Then comes sample. A subset of data taken from some large population or process is a sample. It is a portion of population selected for detailed analysis. As I said, for example, manufacturing of a nozzle itself, there were 100 nozzles. We tested only 5 out of them. That is 5% of the overall population. The sample size is there. 100 total size, population, that is also called lot size. And we have 5 as a sample size. Random sample, if each item in the population has an equal opportunity of being selected, it is called random sampling. This definition is applicable to both infinite and finite population. Data, centrally known facts from which conclusions can be drawn, is data. Statistical data, raw material for a statistical investigation which are obtained whenever measurements or observations are made. This is statistical data. It is very important to understand here. I am looking at the last line here, primary data and secondary data. Data could be taken from both the sources. If data is collected right now through experimentation, that is primary data. If data is taken through the recorded portion that is already there in the books or the journals, or maybe some of the specific websites are there. For example, Provis is a website that provides data about the economy, financial growth, economic input, output, life cycle analysis, that is EIOLCA. That is a website that provides data about the overall carbon footprint that is being produced for specific kind of the manufacturing. For example, in automobile industry, in pharma industry, what is the carbon footprint? This all would be secondary data taken from the sources which are verified by somebody, and these sources are also somewhat authentic. This is secondary data. Primary data is if I take my own data, if I do all my own measurements on the specific 5 nozzles that I have selected. These 5 samples are measured using vernier caliper, using micrometer, using the non-contact method, etc. that is primary data being collected, that is data collection. We will talk about the steps of the statistical analysis. Data collection is the first step. Now, two types of data are there: quantitative data, data of a certain group of individuals which is expressed numerically; qualitative data, data of a certain group of individuals that is not expressed numerically. Anything that we are talking about right now is a quantitative data: height of the specific sample size that you have taken, the size or the diameter of the nozzle that is there, the weight of the nozzle that you have selected. These are all quantitative numbers. Qualitative: nozzle color, acceptable, not acceptable, qualitative data. Nozzle received, not received, qualitative data. Whether color is black, white, in which box do you put it? Qualitative data. Nozzle correct, not correct, whatever we talked about, acceptable, not acceptable, this is all qualitative data. When I am even talking about the rating between 1 to 5, that is also a qualitative data. Rating 1, 2, 3, 4, 5, this could be quantified. Quantitative data could also be qualified. Both of the ways the data could have a kind of an change of the scales. Variable. Variable is a factor or characteristic that can take on different possible values or outcomes. We talked about efficiency of the boiler would be this. The size of the specific component, that is 2.5 micrometer roughness, that is variable here is roughness. I talked about response parameter. Whatever response parameter I talked about in the examples given for the descriptive and inference statistics, those were all variables. Variable can be qualitative or quantitative, that is numeric, or we also call it metric when we talk about quantitative, and qualitative is non-metric. Example: income, height, weight, sex, age, these are all kind of the variables of a certain group of individuals are examples of variables. Survey, or you call it inspection. These are of two types: census survey, sample survey. Census survey is way of obtaining data referring to the entire population, including total coverage of the population. Sample survey is way of obtaining data referring to a portion of entire population consisting only a partial coverage of the population. Census, as you know the mean, this is known as 100% inspection. Each and every component, each and every part that you are making would be tested for the specific kind of a parameter, for the diameter of the nozzle or the internal diameter of the nozzle that goes into the hole, specific diameter. Each and every nozzle, if you survey or if you inspect that 100 nozzles you have total suppose produced a lot size, 100 out of 100 you do, that is census survey. If you select a specific sample of 5 or 10 or whatever number you decide on it, that is a sample survey. Sample survey has its advantages. The time spent on this overall inspection is lesser. In census survey, sometimes the non-destructive testing is there. For example, if you need to see the internal properties of the nozzle, you might have to cut the nozzle and try to see the internal properties of the nozzle using multiple techniques. Then that is a non-destructive testing. If you do it for all of them, you would have nothing left with. All the 100 nozzles will be destroyed. In the sample survey, you are destroying only 5 nozzles to test whether other 95 remaining pieces, what is the kind of the behavior of their internal material characteristics. So that is sample survey. Both of them have their own pros and cons, and generally we do sample survey so that we save on resources in time, in money, in kind of the overall manpower, etc., kind of the resources we use. Then that is why we have inference statistics based upon the hypothesis testing. This will be covered in the third lecture of this week. Stages or steps in statistical investigation. First is we collect the data. Data collection could be primary, could be secondary. Primary data is anyway one of the ways which specific parameter you are going to work upon, which range you are working to work upon, what is your overall domain of the work, that is primary data selection criteria. Secondary data is also very important to be thought of. Which kind of the data source you are trying to refer to, and about that data source there will be very large amount of data. Nowadays we talk about big data analytics. We talked about a lot of other techniques which are there, for example Hadoop, multiple techniques are there. Large data is there. Each second weather reporting is happening at each area. In Kanpur, each second what is the weather reporting that is happening. This generates a large amount of data throughout India, throughout world. Out of this overall data, what is the kind of secondary data that is under your study you need to select? That is right collection of the data. Then organizing the data. Organizing the data in a way so that you try to plan your analysis accordingly. Whether you will take data, for example, if I selected 100 nozzles, specific data, 100 pieces, organizing them. I will take maybe inspection in 2 stages. First stage, I will take 3 samples. In the second stage, I will take 2 samples. First, I will take 2-3 samples to be tested. If those are correct, then it is okay. If those are not correct, one of them is not good, then we will take another 2 samples. Kind of the way we organize the data. Then presentation of data. This is very important. We will talk about graphical and tabular form of the data presentation. Whatever tables you see when you have population, the tables to be drawn with fields, rows and columns, that is a tabular presentation of the data. Graphical presentation is when you try to draw between 2 columns or between certain rows, etc. When you try to draw the data in a kind of a graphical form, that is graphical presentation of the data. Analysis of data, then interpretation of the data. This is all we are talking about statistical investigation. Collection of the data. This is the process of gathering information about the variable of interest. Data serves as the input for statistical investigations. Data can be obtained from primary sources, that is direct collection, or secondary sources, that is existing data. Organization of data. Organization of data includes 3 major steps. Editing the data, that is checking or removing inconsistencies or irrelevant data, whether there is a missing data points, whether there is an extra data points which are not required. Classification, grouping the collected and edited data. Classification of data, when I am talking about organization of data, this could also be in the form of a 80-20 rule, which is a Pareto rule. For 80% of the sample I am talking about, 80% of the sample which is there, I will try to do all the testing there. Whatever testing is done in 80%, whatever results come, I will try to validate those results in the next 20%. That is 80-20 rule within the sample. If I am talking about 80-20 about the nozzle example, total lot size was 100, sample size is 5, 80% is 4 pieces which are being tested. Whatever results come, about the remaining 1 piece, that is 20%, we see whether whatever results have come from that 80% of the sample size, 4 pieces, is valid for that other 20%, that is on the 1 nozzle that is there. Then tabulation of data is also organizing, arranging the classified data into tables. Presentation of data, displaying data through charts, pictures, diagrams, histograms and graphs, etc. It aims to make data easily understandable and visually appealing. Analysis of data, this involves calculating statistical measures such as averages and measures of dispersion. This includes hypothesis testing, regression analysis and other mathematical operations. Advanced analysis may require knowledge of higher level mathematics. Interpretation of data, interpreting statistical results to draw valid conclusions and inferences. This stage requires significant skill and accuracy. Correct interpretation leads to valid conclusions and informed decisions. Incorrect interpretation can result in misleading conclusions and undermining study objectives. I will talk about type 1 and type 2 errors. That is, incorrect interpretation could also result in something not great. Just to recall the concept of primary and secondary data, with this I will close this part or the first part of this week. Classification of data based upon source. Primary data, that is data collected for the purpose of specific study. It can be obtained by direct person observation, direct or indirect oral interviews when I am talking about data for the administrative purposes, that is interviews, or I will say experiments. Administrating questionnaires. Secondary data refers to data collected earlier for some purpose other than the current analysis that is being undertaken. It can be obtained from external secondary data sources, that is government and non-government publication, gazettes, etc., or internal secondary data sources, that is data generated within the organization in the process of routine business activities, for example, production records, inventory. For example, if I need to do something about my nozzle manufacturing itself. In the nozzle manufacturing, I could see some other student at IIT Kanpur itself has done some experimentation on nozzles. What were the results that he has taken, or the specific kind of the machine where he has done the testing? That is within the organization I am talking about, right? Then external data sources, there are handbooks on the nozzles for boilers. There are handbooks on the nozzles itself, the kind of nozzles being used. What are the handbooks? Those are kind of the gadgets or the handbooks which are there. Manufacturing handbooks. Those could be referred. So, those are external secondary data sources. Then data could be qualitative, that is non-numerical. Data could be quantitative, that is numeric. I am stressing this a lot because this I will keep using in the forthcoming lectures. With this I am closing this lecture. I will come to the second lecture where I will talk about the descriptive statistics process in detail. Then I will talk about inferential statistics in the third part, and further then I will talk about the hypothesis testing and design of experiments. Then I will close this course. Thank you.